Hello, good morning, good afternoon, good evening, everyone. Welcome on the Learn Grasshopper live session. Today will be new workshop. My guest is Edwin. Hello, Edwin. Can you hear me?
Yes, I can hear you. Hello, everyone.
Nice to have you online. Actually, nice to see you after we met in Poland. When was that? It was in June, right? On the McNeil
Yeah.
event in
hmm
June.
Yes, I
Have you
think that's
have
right.
you have you enjoyed stay in Poland?
Yeah, pretty much. I like Poland.
Just before we went live, Edwin said that he was attending Polish wedding in the Polish
Just that.
mountains. So that sounds
Mm-hmm.
when you sounded when you told me where was that. So actually, it sounds like epic. Hello, Alexander. If you Alexander is with us, if you can just write if you can hear us well, me and Edwin, and if you can see the screen. So we will start in just couple of minutes. So just 3 minutes left. So Edwin, you are working on in Shape Diver. How long are you working there?
Yeah, I've been working since 2018, already 6 years. And yeah, I work basically as the project manager and the main computational designer.
Mm-hmm.
Um, and well, for us, the speed of the models is very important. So that's why in these 6 years, um, I've been able to gather so many tips and tricks that are very important to make your models look well, compute as fast as possible. So the reason why I am good at optimizing models is because, well, in ShapeDiver we compute everything in the cloud, and the
Mm-hmm.
cloud means server time, no, that you need to pay, and then the less computation time that you spend on those servers, the best is gonna be for also the money that you spend in those servers, and the
Mm-hmm.
best also for your users, not the users of your applications.
I can confirm that Edwin is an expert in the optimization, even when we've been preparing of this presentation. So I learned a lot from that one. So I appreciate. I'm looking forward to presenting all the tips and tricks. We have gathered some of them. We have Mario. So hola Edwin. Maybe you know.
Hola, hola.
Uh, we have the Pashua. Jest dobrze. Do you know what does it mean? Jest dobrze.
Dobrze, like good, no?
Yeah. Everything, everything good.
Good.
So in 2 minutes we will start. Maybe I will start with this little bit question. We have some people already here alive. Before we are starting in just 2 minutes. Do you struggle with slow Grasshopper scripts? Just share, Mario, Alexander, if you can just, all the rest, if you are with us, just write. If do you have any problems with scripts and what kind of problems? Because when you are building your script with the visual programming, you're adding more and more components, and of course, visual programming has some limitation. So in some points, maybe you can meet these problems. So today we are going to present some tips that can help with that. We have people from Turkey. That's good to see people worldwide. Let me see. Just prepare your water and your coffee or tea, and we'll start in just couple of seconds. Mario says that maybe with Tekla when inserting components that create bolts. That I struggle with as well. So I will today share one tip for that, because this was my problem as well. And I think this is also a problem with every live link connection, because you have to connect to Tekla or Revit or other software API, and you have to do it in the proper way. So today Mario will share some tips about that. So stay with us. Perfect. I would like to add also that Edwin has a own channel on the Shape Diver. It's lots of great videos with sharing tips and tricks. What is the name of the channel?
Just ShapeDiver. Let's look at ShapeDiver, and there you can find, well, everything to do with Shapediver, of course, but we also share a lot of things that are specifically Grasshopper related. So it's not just about Shapediver, but many things about Grasshopper.
Cool. Okay, so we have 2 p.m. Central European time. We have already almost 100 people. So let's get started. We are, as always, on Facebook, LinkedIn, and YouTube. Actually, we are on the YouTube on Learn Grasshopper and Shapediver. That's right. Shapediver YouTube. So we will appreciate if you are watching on one of these platforms, if you can just leave a like, subscribe, so it will help us a lot. So today's webinar, we will try to keep it in 1.5 hours. Afterwards, if there will be some question, we will have a Q&A session. So please stay with us. But we are going to share 12 tips. So we have divided the time for some couple of minutes for every tip. And then if there will be more questions, so we will try to answer. If there will be no, we will try to make it shorter. So recordings will be available to watch later, and link will be sent to all registered users through the email. So if you haven't received any email from Learn Grasshopper, so you have to register. So go to learngrasshopper.com/workshop-optimize. You can also scan this code. Edwin is also going to share some of the Grasshopper script that he prepared, some tips, some with the examples. So I think it's really useful also to register to get this Grasshopper script and test it for yourself, especially when it comes to optimizing solids and meshes. And the last one, we are organizing this session for you. So if you will have any question to Grasshopper, to maybe you have some other problems that we don't have on the list, so please write what you are struggling with Grasshopper most. So maybe we will try to help you answer. We have some ML is with us. Hi guys, nice to take a part of the workshop. Nice from you. That's cool. So for those who don't know me, my name is Krzysztof Wojsław. I'm Polish. I've been working as a bridge designer for 10 years. Now I'm 100% on education. So I have created educational platform when I'm trying to transform engineering work into fun, and I'm teaching them programming. So already 15,000 people are following me on newsletter, and we have already 2,000 people on our platform. But in addition, I'm really also close to university when we are having Grasshopper, Python, and C# lessons already at the university. So we are already promoting this way of working. But this is enough about me. Today, my guest is Edwin Hernandez Gomez. Hello, Edwin. Hello again. So he works as a lead computational designer and project manager at Shapediver. As you said before we started, you started in Shapediver in 2018. That's right?
Yes, correct.
And before, have you been working already with Grasshopper, or you came with some Grasshopper knowledge, or it was from the scratch?
Actually, I mean, the time when I started to hardcore work in Grasshopper was when I came to work for Shapediver. Before that, the first time I was introduced to Grasshopper, I think, was in 2014, because I was studying architecture in Colombia. I'm originally from Colombia, and there it was the first introduction to Grasshopper. But then I was mainly focusing on Beam. Actually, now Beam is becoming so popular, but I was in like 2014 already working with Beam.
Before it was
Especially with
cool.
ArchiCAD.
Before it was cool.
Exactly. Before I was thinking like maybe I should have stayed also with Beam. Back then I was teaching people in Australia, where I was also studying computer animation. And I was teaching people how to use ArchiCAD, which is Revit is a lot as well in many countries, but ArchiCAD is very strong in Australia. So that's why I was teaching mainly ArchiCAD, and then I went back into Grasshopper because I started to create online configurators, and the tools that I was using were not enough. I was using like Cinema 4D and like very static geometry, and that's how I came back to Grasshopper, because it's completely parametric, completely created on the fly. and that gives me the complete freedom of create as complex of configurators as I want. And that's how I ended up then in Shapediver, by creating configurators first with other technologies and then realizing actually Grasshopper is the best way to do it. And then, well, Shapediver was the one that was doing it through like making the option to offer these Grasshopper scripts through the web, which is what I was already doing with other technologies. So that's how I ended up in Shapediver.
Yeah, and today Edwin is going to share his experience, how you can optimize your script. We are going to present 12 tips. So I will show, this is the agenda for today. This is what we are going to present. We are going through all 12 of them. We are going to come back to this picture so you will know where we are. So let's get started. I think we're already lots of people are already here. So let's get started with some first tip. I will start before going to all the tips how you can make your script faster. First, actually, you should check with the tools like Performance Analyzer from Pancake or Bottleneck from the MetaHopper, what actually is slowing your script down. So in most cases, that can be some solid operation. In my case, it was always when I try to look up for what is slowing down my script. It was some solid operation or some cluster that was not optimized. This is always two options, but maybe in your case will be some other components. So I really recommend to go to MetaHopper or to Pancake, download these two plugins and check first what is slowing you down. Before you are starting to optimize, just try to explore your script and find out what can be wrong. Are you using, Edwin, other tools than these two? Do you have also?
I use mainly MetaHopper, and I mean natively Grasshopper also have the profiler, which is also, I mean, you can see it in the canvas. You can see directly how many seconds or milliseconds is a component using. So that's like a first look in case you are looking at some components directly in the canvas. But well, the nice thing of MetaHopper is that it gives you a list, no? And when you click on this list, the canvas takes you exactly to this component, so you know exactly where you have to focus.
Yeah, this is the best part, because when you are using the search function, so you just double click, so you will be directed to this component, and you can just make some same operation. So first tip: try before optimizing, just check what to optimize, because maybe you can optimize the wrong part of your script. So this is the first what we started. The second one is really obvious about the curves. Especially when you are importing lots of curves or other geometry. It doesn't have to be just curves, but it can be also like meshes or surfaces from other softwares than it was defined in Rhino. Because if you are defining your curves in Rhino, they should supposed to be already made in the optimal way. The polynomial should not be that advanced. So every time when you are importing like some 3D geometry from the DVG file or from other software, so please try to play it with a little bit. If you are really into precision, so maybe you have to use more advanced components, like if you have some millimeters precision. So maybe rebuilding geometry of your total curve can be more difficult. But if you don't care like about the millimeters tolerances, so actually you can go with the rebuild curve, like a simplify curve, or even change the really complex curve with a huge polynomial expression to polyline. Maybe in some cases there will be straight lines. It doesn't care on your project if you just have a cross section like 2 millimeters in one direction, especially if you are working in the infrastructure project. Maybe in your case, Edwin, you worked more with the product, so maybe it's more like a precision. What kind of precision are you working usually when you work with the curves? It's like about millimeters. What is your experience with that?
Yeah, I mainly work with millimeters, but I mean, we always do the distinction of what needs to be done for visualization and what needs to be done for production. So we normally have two paths, two scripts, let's say, one that is for production, which takes maybe longer, and one that is for visualization, where the user is just quickly iterating and changing things, and then is where we use a lot of polylines, especially. And then for the one for precision, then we do need to have the precision now, because then this is used for laser cutting or for CNC machines, and then you need to have precision when you do this kind of operations.
Yeah, so first thing that you can do when after you are importing some curves or geometry into Rhino, or you have some geometry already in Grasshopper, I really recommend to bake it and just to click it, as you can see right now. So here you can see that there are lots of points are defined, and this is actually definition of really bad curve. So you can see that the distance is not divided in the constant distance between points, as in the second example, when you have the same distance for every, and it's actually not the full definition of the correct curve, but it's supposed to be like all the control points supposed to define like the really well distributed control points over the curve. So really pay attention to that one. And I said, if you don't care about that much about tolerances, you can easily change this to the polyline, and you will see the difference when you are going to make some loft sweeps. If you are doing that on the polyline, it will make like, I don't know, maybe five times faster, because the expression, mathematical expression, it's really easy to follow. So second tip, always when you are importing some geometry into Rhino, try to transform this geometry into Rhino geometry. So it will be native created geometry through Rhino. And actually, if you will, after in the more advanced script, when you are working with maybe some Python scripts or you're using advanced plugins, it will help you a lot, because if you're using this native NURBS curves, you will have much easier work to do, and you can omit lots of problems. Okay, so that was the second one. The third one from my side is live links. Before we started, we asked about what do you struggle with Grasshopper, and yeah, we got the answer from Alexander. Most problems with Tekla, like Mario, like inserting components that create bolts, and yeah, this was also my case. And actually, this is some of the things we have to live with, because we have to connect through the API, through the different softwares. Like in this case, most of the used API connection are Tekla, Revit, and Archicad. And all of them they has this live link connection. And usually when you have really complicated geometry, and if you are sending in the bulk lots of geometry, it can stand for loading, and you have to wait, because this Grasshopper has to connect with the API of the software, then come back to Grasshopper, and then create all the object, and sometimes nothing that we can do. But there is one tip that I really recommend, to actually when you are opening scripts, or when you are creating new objects, actually to use two components that I really recommend. One is a group toggle, and second one is enable disable objects. Actually, the way how they are work. They can be downloaded from the MetaHopper. So if you download MetaHopper, the two components are there. So the first one, group toggle, is just a button. So you can see here, maybe I can just show my laser. So here is a toggle group. So actually, when you are going to add this one small button to the group, so it will be inside group, and if you will click it, so it will disable all the components. And actually, when enabling, so all the components will be enabled. So this is really fun thing to do. Just add one button to one the group, and just click it, so it will activate it. The same you can do actually when you are going to select, if you would like to just select some of the components. Let me see, if you would like to just select components that are creating object or creating components, so please just do it in order, and you can create some couple of buttons. So every time when you are updating your script, so you are clicking some 3 buttons and you are enabling once, so it will activate, then going to second one, activate. Because if you are going to activate all the ones, so there will be a bottleneck into the API of all the software, and this can help you a lot. We have some comments here from the Victor. When I change 2000 trusses in Tekla model in one, when all trusses selected, Tekla stacks crashes. And this can happen, especially if you have 2000 elements. So Victor, try to use these tips and try not to create all the components at once. Try to break down them into some parts and enable and disable that one. We talked about that, Edwin, but you haven't had any issues with that. When you were creating some objects, about enabling and disabling some components in order. You said that in your case everything was fine with that.
Well, for enabling and disabling, we use mainly that. I mean, of course, not with Tekla. We don't specialize in structural engineering, but we use it mostly for this part that I said, that sometimes you want a section of the script to be for manufacturing, a section of the script to be for visualization. So of course we would disable all of the part of manufacturing while the person is just iterating. So you basically, they say, shut down sections of your script when they are not needed.
Okay, so that was, I started with these three tips. So let's now, like, in my opinion, are the basics, like over this kind of more specific tips. But now let's go to more into specific components, and we will start with the solid operation. So here Edwin will show his example. So what do we see on the left side? What is that?
Well, this is just a very simple example of a lamp that you can do with laser cutting. These are just some wooden elements that can be cut easily with a laser cut, and then you can assemble this lamp. It's a very simple example, but it will help us understand the principles. And then, of course, these principles then can be used for whatever you want. We have created very complex models also in engineering, but the principles are always the same, even if you go to a very simple example. Okay, so well, I will get started then with the tip, which is optimizing solid operations. So as you can see here, this component is taking, well, this cluster is taking 5.4 seconds to compute.
And just before, can you just show on the screen where you can activate the profile so people can see this 4 seconds? So we are on the same page.
Here in display, canvas widget, you have here profiler.
Yeah.
Okay. So, and then when you activate it, actually, if you right click on one of these ones, it also tells you when you want to show it. So for example, here I wanted to show it up to the minimum because then I want to show very specific, but sometimes it really doesn't matter. So if I say up to 50 milliseconds, so anything that is below 50 milliseconds, then will disappear the profiler. And if I go 1 millisecond, or I think none should show it always. Yeah, I mean, but that's like 0 milliseconds, doesn't make sense anymore. So that's why I put it like 1 millisecond.
Will also, and for sure, this will also slow down your script if every component will have this small widget. And if you think about if you have 1,000 of components on your Grasshopper, so this will also slow down your work.
Yeah, so I mean, that's why, I mean, here I'm showing it for this amount, but it's just for, because we are focusing on that. But yeah, here you can also decide when to show it and where not. Even there is a custom threshold. And yeah, that will then here we can easily start to see which components are taking the most, no? In this one. So, I mean, I will be saying some small tips here and there as well. The main one that we are focusing here is on the solid difference. So here you can see that's of course what is taking the majority of the time, 5.3 seconds. And what I'm doing is I have these circular elements, and then I'm doing a difference with the, let's call it rips, so that we can end up with the notches. That is where you will be doing the installation of your rips and be able to create the lamp. No, so that will be like the quickest way to do it in terms of how much time you spend thinking about your grasshopper file. You just put this component and that's it. But of course, that's when you have to think. These are like very simple steps that you can do to make your model work faster. No, so the thing here is that, of course, if I know that every single one of these rips is just being rotated, that means that basically every single one of them is identical. So if I know that every single one of them is identical, well, then I just need to do the difference in one of them. So I just take one of them, I do the difference. As you can see, of course, takes way less. And then is when then we could, after we do this difference, start to do the rotation of the rips. That's a very simple tip, but I have reviewed many Grasshopper scripts, and sometimes people don't do these little steps. So just consider that and try to avoid doing solid operations in objects that are just going to be identical.
Yeah,
And
this is
then
I really like it because it's not that obvious, because when you're creating, so you're thinking about the end result, so you're creating the whole structure, but actually this is like to break down it a little bit, so it's huge. But we have to add some computational time to also rotate, right, to make some transformation, but in this case it will be nothing. Yeah, because it will be just mathematical operation, and yeah, just we are going to talk about it later.
Correct. And then here I just have a very small one as well. The offset component, that what takes a while also to compute always. The reason is because the offset component is optimizing to get the same distance, real distance between the curve, the original curve, and the curve that you are offsetting, which sometimes you don't need. Sometimes it may be necessary, but sometimes it may not be necessary, for which I would recommend instead using the offset curve loose component, which
Can you just a little bit zoom in? So
yeah, so this one, instead of offsetting the curve and making sure that the real distance of the two curves is whatever distance I give it here, this one is offsetting the control points, which is of course way faster. And then of course that also depends on how clean is your curves. That is what Kris showed at the beginning. If you have a lot of control points, maybe it will take longer, but it's way faster than doing the normal offset component.
Actually, it's 50 times faster. So it's like a
exactly.
huge difference.
Correct. And many times offsetting the control points is more than enough. So that's a small tip there as well regarding the offset component.
Cool. I like this as well. And we have the comment from Alexander. Very good tip with the profile threshold. I wasn't aware of that.
Perfect. Nice. Okay, let's go to the next one.
Yeah, so we talked about the solid operation. So let's now go to split operation.
Yeah. So how can we avoid solid operations? Because that's actually what takes the most. No, so if we check the intersection tab in Grasshopper, the solid operations are in the shaped section, and these ones are normally that take the most time. So basically, if we know that the solid operations is what take the most time, then we need to find alternatives to them. And well, the first alternative will be, instead of doing a difference, you can just do a split, which takes less time. So as you can see here, we went from 5.4 to 182 milliseconds, and if we see the result, it's exactly the same. And that's a huge difference. And then if we see what we are doing here,
so basically it's the same script that you made some improvements, right?
Correct. If you see, it's almost the same everything. Of course, I already implemented, for example, the use of the offset loose component, and then I create this surface. But then what I do is, instead of doing a a solid difference, I just take my original rip and I create some rectangles where the notches are gonna go, and then I use the split operations component instead. Then, of course, this one we need to do an additional step, because in this one we need to then tell it what is useful and what is not. No, like what do I have to just throw away, because of course we don't need all of these small ones. So a simple way that I've seen many Grasshopper developers doing it is they assume that the list order is always the same. So here we could say, I think here is always the last one. So I could just do a list item selection and take -1, the last one, and then that's it. You could do that, but this could break your model in future versions of Rhino. In Shapediver, we have Shapediver, I think, since Rhino 5, and every single time Rhino has released a new version, Rhino 6, Rhino 7, and now we're in Rhino 8. For some reason, this list order always changes.
Yeah, because when you're exploding like a BRAP, so if there will be some change in the definition of the NURBS or of the geometry, so sometimes when you just hard code like this one, that you are taking just the second or the last element, so it's not the most optimal way. And yeah, this is a really good tip to not do it like that.
Assume.
Just spend, to not just assume that it will be always like that.
Correct. And it's not just what I say, it's not just like that maybe your original geometry may change, but it's just the Rhino version changes, and even with the same geometry, it just completely shifts the order. So just to make sure that your model is compatible in between versions of Rhino, that all of a sudden, oops, my model doesn't work when I upload it in Shapediver. Well, maybe because you created it in Rhino 5 and Shapediver is in Rhino 6 or Rhino 7. And then, of course, if you try that in your local machine, it will be exactly the same. You will have the same problems because the different versions do it in different ways. So here, what you can always do is, of course, you can always rely on mathematical operations. So here I do an additional check of area, and then I know that now I can take the last one because now I know this is ordered by area. So I know the one with the most area is the one that I need to select. And then is when I do the final selection, and then I continue from there. And this is what I was saying in the previous tip, where I just create once this geometry. It's just created once, and then I rotate it. And as you can see, this rotation takes a bit of time, but it's just 18 milliseconds.
Yeah,
in comparison
like
of these 5.2 milliseconds.
Yeah, just to say, like 18 milliseconds is nothing. So if you see 18 millimeters, it doesn't have to optimize this component.
Correct. And then, well, there is other kinds of split components. So we have, I'm using here the surface split component, but we also have, for example, here the split BRAP component. For that, I have another example, golf ball. Here is just like creating a golf ball. No, like how do you do that in the most optimal way? No, it's a sphere with a lot of little spheres that you have to somehow subtract. So if you do it in the most direct way, I even have to take a screenshot because otherwise we will spend here some time trying to see how much it's gonna take. It takes 40.7 milliseconds if you do it just like that. No? So I have
40.7 seconds, not milliseconds. So
sorry, milliseconds. Seconds. Good point. Yeah, seconds. So here we have the sphere, and you have here all of the small spheres, and that's the subtraction that we are trying to do. Yeah, here is loading the rendering. That's only something that I also have to explain later. Okay, so we are doing this subtraction. The second option that we have here, I'm using this split method. This one still takes some time, 20.1 seconds, but well, already we split by half. I'm disabling all of this again because otherwise it would take a while. But you see here, I'm using the split components, and basically then I split them, and then I have to do something similar with where I have to decide what is useful and what is not. And this is the containments that I'm checking here. Which part of the surface do I keep? Which part of the surface do I just throw away? but this is still taking 20.1 seconds. And then I have a third option, which gives us the exact same result, and this one takes 4.8 seconds. So we went from 40.7 seconds to 4.8 seconds, and we get the same result. Let's see what we are doing there.
And what is inside? How you reduce that by 10 times?
Let's see. So here I'm using the same surface split component. So I take my big sphere, I have all of my small spheres, and then I use this BRAP component, which is in the physical tab. So as you can see, all of these components that we have in the physical tab are way faster. So before I was using the split one, which is still cut in half my time. But then when I go into the physical tab uses other methods that are way faster to compute. So that's why, for example, here we have the surface split and the BRAP intersection. And this BRAP intersection, what gives me is all of the curves that create where the BRAPs intersect. And then with that, I can then take the surface split and do the same that I did in the previous example. And then I have to do the same, of course, where I have to check, okay, what is useful, what do I have to keep, and what I don't have to keep. In this case, I'm just using some bounding boxes for the big one, because for the big one is the same situation. I just want the biggest one, so I just use the bounding box to do that operation. I could do it in many other ways. Here I do it because, of course, creating a bounding box is super quick to compute, and because I know it's always a sphere, then that's good enough. And in the other side, I do a containment. So I have the original sphere, and then whatever is inside the sphere of these fractioned surfaces is what is useful for me to keep. And that's how I end up with the final result.
That was really smart way of doing that.
So that's how you can really cut it down. Okay, so let's go to the next one.
Okay. Just before, we have some question. How you make input value to be visible on the component icon? So what plugin?
Yeah, that's a plugin. That's what is it? I think it's Persistent Data Editor. I don't know if that's the name of the plugin, but that's how it's called here.
Yes, yeah,
probably
yeah.
called like that.
Yeah, I think it's. I have it on my computer as well. It's called Persistent Data Editor, and you can switch it and turn it off every time. It's near pencil, right? Somewhere near the sketch function. When you turn it on, I think, yeah, here you can turn it on, but I think when you have the pencil sketch function in Grasshopper, so there is also, you can turn it off, yeah, somewhere this one, yeah, correct. So you can turn it. And one more question. I think this is a really good question and can be really important for many. Do you have a tip for sorting splitted surfaces? I see you choose the one with the biggest area, but that wouldn't work in my case. I need a different parameters. So in your case, you showed one when you checked the surface, like the area of all the surfaces, and you choose it not the biggest but the smallest one. And the second in the second script, you show that you created bounding boxes. So this is also a way. I have some tips also, but do you have also other recommendation? What are you using?
Well, the thing here is that it's so dependent on the use case. So there is so many options that you can do. So yeah, we'll have to think of use case by use case. But in general, I mean, you need to have some sort of a connection to the geometry, either the size, the area, containment. So you see that I do also containment checks.
This is also a good one. This is a good one.
Yeah. So where I have the original sphere, which is not cut. No, that's a closed sphere, closed BRAP. And then I do a point in BRAP containment, and then that I do it by also taking the bounding box of my fragmented sections, and then I take the center of this bounding box, and then I do a containment. And then, of course, what is inside is what I keep. That's another way. But of course, every use case can have its own way and could be even more optimized when you have a specific goal. Then you can optimize it to the fullest. Of course, it's not as generic, but if you know that's the only thing that you need, then you should of course, go through the route that is not a generic, but is the most optimized.
If you can come back to the previous example with the lamp, can you just show it? So when I was thinking about like the if you feel it, if you're looking for another, and if you can just show the splitting, how do you split that with the other B-wraps? Yeah, with this, for example. Yeah, if you would like to sort it out when you have cutted it already and you have these small surfaces. So for example, if you are going to find out this outer curve for this longer part, and if you can check the distance between the center of this small part to this curve, and if you can, for example, this is just one idea, or maybe if you have a middle line between this two long one. Let me see. I cannot.
I mean, and there is many options, no? So here is another one that I just saw. For example, you can get the center of all of your surfaces, and then do again a containment, but it will be a 2D containment, no? So there are two types of containment. I will talk about the other one later. But I think this one is region. I know it's curve here. Analysis, point in curve, or even better is point in curves. Because here we're selecting many curves that are the rectangles, and then I want to test if these points are contained in these curves, and then this will tell me the relationship, and then whatever I know that is inside is what I need to remove, whatever is outside is what I need to keep. So it should happen that if I do this, then this should be even quicker than what I'm doing here. So you see, I even already optimized a bit more here. This, if I do this, it didn't work. Why? I'm missing something. Yeah, well, that's the problem here. This point of the center ended up also inside. That's a bad luck. So we will have to think of other ideas, but that could have been a good idea if somehow I can get a point there without. I mean, another one could be, for example, if I go curve. If you take a surface and you put it into a curve, that gives you the perimeter, the boundary. Yeah. Then I could take the middle of the curve or sample the curve somewhere. That could be another option, and maybe this one could work, but yeah, we still have the risk that we will end up with the point of this being inside. Yeah. But there is, I mean, if you know how is your curve, you could always end up with a point somewhere here, and then do a containment. So a containment is a good idea. Just you have to do a bit more of steps there to make sure that the big one doesn't end up.
I can recommend a curve closest point, or maybe project a point on a surface, and there is one parameter there as a distance. So actually, you can project all your points that the centers to. I think it's called. Yeah, it's not this one. Let me see. I think it's a closest point. Let me see. It's, I think, B-wrap closest point. Yeah, B-wrap closest point. If you can take this one. And this is also, I use that really a lot, because you can, if you have your point and you can project on your B-wrap, or maybe not in this case, but also you can project it not in the B-wrap, but also on the curve. So you actually can have a distance, and for example, you can sort it out if you know that this distance to this curve on the right side is like 20 millimeters. So you can take a pattern and just take off all that one is like longer 100 or something like that. So Philip, this is just ideas when you can just think about these components and try to use it. If you just before going to the last one, with the sphere example, we have some question from Fabrizio. 4 seconds is still a lot. Is it still possible to optimize? And this is for sure. We are going to the next one. So yeah, we've been talking about the split operation. So it was faster, but still not that fast. Now we are going to the next one, which is the region operation. So we are going to be much more faster.
So let's go to the region operations. So for this one, I have a different example. So in this case, I want to create a pattern. So here, I want to create a pattern between these rectangles and these circles. No, so I want the pattern that creates the difference between these two. So what is the easiest? Well, to do a region difference. So if I enable this, it will take some time, but not much. Let's see, 6.2 seconds takes this one. If I just take it directly like that, no? If I just take these rectangles and take out these circles, it takes 6.2 seconds if I just do it directly. But then you can be also clever in the way you use your region operations. Now, region operations start to be more optimized because you are no longer in a 3D space. You are now in a 2D space. So you can do a lot of these checks that we were saying of containment, etc. But here, for example, I have a very simple optimization using still this, where we go to 247. But what I do is a collision detection. So I take my rectangles, I convert it into boundary surfaces, and then I do a collision detection between these circles and these rectangles. What this allows me to do is, okay, if you collide, then you belong to this rectangle. And in that way, I'm grouping in branches what is relevant. So I'm not completely colliding everything with everything, but I'm really grouping everything into branches so that when the component is computing, is just considering what is relevant. So, for example, a lot of curves, circles that were very far away, they were not even relevant for anything at all. So they could be completely removed, and everything else could be grouped. So at the end, that's how you can end up with way less computation by grouping doing small checks like collision in this case, grouping your geometry into branches, and then just operating in branches. That even happens also, for example, with the very used component is the joint curves component. This one normally is fast, but when you start to have a lot of curves, it can become slow as well. And similar situation happen here. If you start to group everything in branches, what is relevant, you don't lose your data structure, your data tree structure. Then you can also optimize the joint curves and many components if you keep everything grouped in relevant geometry groups.
Yeah, I really like this one because it's like helping a little bit Grasshopper. Like, hey, Grasshopper, focus on this. I will filter for you the circles that are not relevant. This is the first step that you made, and the second step that you made, I will group for you because you don't have to cut try to cut with some circles that are not containing. Cool.
Correct. Yeah, and I think we can go to the next tip.
Cool. And the next one, when we talked about from the region, about the polyline, right? Region.
Correct. So, correct. So right now we worked still with North's curves, no? So they are not polyline curves. But if you don't need as much precision, that was basically what Kris was saying at the beginning with tip number 2, I think, about the curves, then you can use polylines, and polylines are way faster to compute. So in this case, before I do anything with my curve, I'm converting it to a polyline. So I have my curve as norths, then I convert it to polyline, and then I use this component that comes from the Bowerbird plugin.
Is it for free available from Food to Rhino?
Correct. It's just input for Rhino. You can find it there. And here you have this polyline section in this plugin, and this has all of these same things that you have in the native Grasshopper components. In the intersection, you have all of these region, intersection, etc. You have the same thing, but for polylines. So the difference, intersection, the same thing. And of course, this computes way faster. So if I enable this takes 160 milliseconds. It says 6 milliseconds. Again, here depends on whether you need that precision or not. For example, here, because this is laser cut, I will just use this for display purposes, or while the user is checking how they want their lamp to look like. But for manufacturing purposes, I do need to have a smooth cure, no, because otherwise the laser is gonna not create a smooth cut.
So just one question. So sometimes when you're preparing some product for shape diver, so you're doing two scripts, like one for make it visual, which is super fast, and second one which is precise. So you're like separating this as well.
Correct. And normally I try to do it something like what you've seen I'm doing. So I'm not like recreating everything from scratch. Like here, basically, I could still use this component, no, and I'm basically reusing the core, and then just in this part there will be a split of what is manufacturing and what is visualization. It's not like I'm completely redoing this. No, all of this core part is completely important and is exactly the same. So I just need to do a difference here. So I really strategically start to do the division of what is manufacturing, what is visualization, what is really necessary, and everything else keeps together. Everything else keeps with the same logic. Otherwise, also becomes a nightmare when it comes to maintenance. No, if you need to update one, then you need to update the second one. Make sure that you have everything always synchronized, etc. Okay. And now the question is, why does it take? Why is way faster? And the reason is because polylines, as Kris explained, are way simpler geometrical form. So here I have a way to visualize it. So here is just a component that converts a curve into a JSON, and then this JSON just visually tell us what creates this curve. No, here, for example, I have a north curve, and it tells me that it has some nodes, it has some control points, and all of this needs to be considered while you are doing any operation in those north curves. So you still keep the same nodes, you still keep the control points as intact as possible. Whereas when I check a polyline is just a list of points. That's all what it is. A polyline is just a list of points. And if it's just a list of points, that means you can do many simple mathematical operations with that. For example, I have here another example that I could have used before for all of these containment checks. That is way faster than the classic point containment operation. So point in curve could become very slow when you have a lot of checks. But if you could convert your curve into a polyline, then you can use this component. Let me see from which plugin this one comes. Yeah, here it is. Clipper, I think it's called. Yeah, Clipper. And this one has the polyline containment, which is way faster to compute, again, because we are just checking a list of points against a point. That's all. So it's way faster to compute. So I recommend to using polylines, not just for creating geometry, but also to create checks. No, I could do a check here of a polyline containment and continue anyways with norths, for example. This is just used for checks, for making geometrical checks.
Really useful. I wasn't aware of that. I never thought about it, that it can be an issue. I was thinking about just checking my geometry, which it's supposed to be polyline. But yeah, that's true. If you are checking some inside curves, so I can imagine that it can some type. And for those who are first time seeing JSON, so actually every time of operation and object you can change to JSON file. That's correct. And are you using JSON a lot?
Yes, we use it a lot in Shape Diver because we create very complex data structures, and then sliders and toggles are not enough and are not scalable. No, and JSON is the best way to communicate with the web, to interchange data with web apps. So that's why we use it a lot.
A question: what was the plugin showing the inputs directly on component, Tobias? So we already show it. Is persistent data editor. So yeah, so lots of people are seeing that your Grasshopper is not looks like theirs. Cool. Let's go to the next one. So this one was about the polyline region. And let's go to the fastest one. So we can say that this is the eagle when it compares to operation time.
Correct. So then we have polylines, but then we can even make it faster, and that's the mathematical operations. So this one, if I connect it here, this was taking 5.4 seconds, and it creates exactly, I mean, there is a small difference there, but that's, again, if it is not that important for you, then it's not an issue. And maybe something that I have to just check in the script, and that's it. But here it produced pretty much the same result, but it takes just 65 milliseconds. So let's go inside and let's see what's happening. So all of this part is the same. I'm creating the curve, etc. But to create the notch, I'm using this operation. I'm using the curve line operation. And that one is in the mathematical section of Grasshopper. So if you go to intersect, mathematical, and then you have here the curve line operation. This is called mathematical because a lot of these components that you see here can be easily expressed in a mathematical formula. The easiest that you could think about is the line-line intersection. It's here, line-line intersection. Like that's one of the fastest operations that you can do. Why? Because I could even completely avoid the operation if I want, using this component. Like there is just a simple mathematical formula that gives me the intersection between two lines. That's it. So it's such a simple mathematical operation that it takes no time. The same happens with the curve line and everything that you see inside the mathematical section. So that's why it takes way less time. And I think I have another example, but well, okay, let me go through here. So I do this. I have basically the notches, and instead of creating a rectangle, I create these lines. Then I have my my offsetted line. Then I do this intersection. And then I just take the parts that are relevant for me. And with those points that intersected, I can now create the notch. I can now create this notch that I have here. So now I have the intersection, and the points that are here. It's just the original ones that come from the ribs. And with that, I can then do this joining of my curve. So I have the interior part. Then I just take the exterior part, and I do a final connection, and then I end up with the same result. Rotation, etc.
So we can see that the difference is that you are building like your build up from scratch, that you are not cutting. So you are just building the curves that are also supposed to be on place, and then you are creating like a volume object by extracting that.
Correct. So I'm going like piece by piece instead of just taking everything together and going piece by piece, building what is relevant here and there. Here I have another example with the same region example that we were checking. And that's the last one that I have here. Take A, mathematical operations. And as you can see, we go from 6.2 to 92 milliseconds. And then we will see why that is. And then I'm doing the same check of collision. Then that groups again in branches my circles to the branches to which is relevant for each of the rectangles. But then I'm using simpler operations. Before I was using still the region difference operation. Now I don't need that. I could just simply do a curve intersection, then do a shattering. So I shatter my curve, and then I do a containment check. I take these curves, I take the points, and I do a containment check to see what is relevant in my rectangles. So you can see, okay, here is going to come a circle, here again. And the same I do below, but to the other side. I'm using both outputs of the curve intersection. The output A for the rectangles, the output B for the circles. And then I do exactly the same, similar. And I also start to remove what is not relevant. And then you end up with this part, and the interior curves are here. And these are the curves that are not doing an intersection, and here are the other ones.
And we can see that, and we can see that this script is longer, like when it comes to number of components, but it's faster. This is also one thing. This is Victor comment here. How not nice looking spaghetti FX script computing speed? I assume it doesn't. So it doesn't matter how many components are you using. It's about the quality of the components that you are using. If you are using the components, for example, as in this case, mathematical operations, so it can be a huge amount of components. It can be like really huge spaghetti monster, but it still can be faster than if you are going to use that with just going with the shape. Will you agree, Edwin?
Half.
Half,
So
okay.
it does matter how many components you have, but normally it starts to become a problem when you have thousands and thousands of components, which you can still avoid. No, it becomes a problem, especially not when you are running it, but especially when you open your Grasshopper script. First of all, your Grasshopper file is going to become heavier as you add more components, because basically more code that is being saved. And when you open the model, if you have a lot of components, normally the first load takes a lot of time to compute. But then again, this becomes an issue when you have thousands of components, which sometimes in spaghetti monsters that happen. But then the issue of a spaghetti monster is that sometimes the Grasshopper developer is not using data trees. For example, sometimes you can see spaghetti monsters, and I can just from afar, you can see, okay, this flow of data looks exactly the same that the one below, then the one below, so basically they are just copy pasting instead of using data trees, for example, or instead of using clusters or other methods to reduce the amount of components that you have. So still for speed, it's important to don't just go crazy and put as many components as you have, but then it's more about like using data trees, clusters, so that you are efficient in how many components you use as well.
And Rego, in meantime, ask, how do you set up the line connection between components to be straight instead of the curvy? So again, the plugin. So it looks like you have thousands of plugins installed, and Edwin.
Yeah, I think these are plugins that I have installed a long time ago. I think it's a Snapping Gecko, or
no,
maybe not.
I think it's not.
I know it's wire rendering.
Yes,
it's wire render.
Correct.
Yeah, I have
it's
it.
a wire rendering.
Wire rendering.
So actually, you can change it into parabolic and into some curvy. Yeah. So in even the line, so you can change it. You can change it there. Okay. So to summarize, so we have this kind of slide that we have the shape components that are really slow, and on the left side we have the mathematical components which are really fast. But Edwin, from your experience, you said that you are working already 6 years with the product development and the script optimization. Have you in your work, have you ever experienced the case that I try everything with the mathematical operation and I gave up, I have to go with the shape components? Is it some cases that you have to use shape, that it doesn't have to be like you cannot do with the mathematical operations?
Well, I think you can do anything with mathematical operations. It's just that it may become a bit too complex, and then is when I would start using C# or Python to create my own custom components, where internally I'm doing like a lot of loops and like very complex things, so that at the end I can avoid still these solid operations. But of course, you have to think a lot of how the data is running. If I can do it a loop, like it becomes very complex in that extent. But I think I have been always able to avoid them. Maybe, yeah, sometimes I had to use the in the mesh section, because I work more with meshes. The mesh difference, mesh union, no, mesh difference mainly. The mesh difference mainly.
But not on the BRAPs, right?
Yeah, and the thing is that in the BRAPs you have all of these splits and all of these other, so you can really reconstruct whatever you want to do step by step. No, so I don't think there is an issue to do it. And when it becomes very complex is when you may need to use, because at the end in C# and in Python you have the Rhino common, and the Rhino common has all what you see in the canvas. All of these components are functions in Rhino Common that you can use there in a more clever way. So then is when I start to use other methods, but inside then a C#, because then it becomes so intricate to do it just with Grasshopper component that it's better just to go directly into C#.
Yeah. So our recommendation, always try to use the mathematical components first. And if you will not find out the figured out way, so maybe in the final stage you can go to more slower but always start with the mathematical. Try to break down how you're going to build your structure, your geometry with the curves and lines. Okay, cool. Should we go to the next one, to the textures?
Yeah.
Or would you like to add something more?
Yeah, I mean, here, if you share, I just wanted to mention, I mean, geometry in general is divided in two main groups. You have the solid geometry and the plane geometry. So even if what you're creating is a solid geometry is 3D, even then you can divide every single 3D piece of geometry into 2D pieces. So all of these geometrical checks and intersections and all of that, if you can decompose it into planar geometry, lines, points, polylines, etc., that will compute faster. Of course, the simpler the geometry, the faster it will go. So that's why I always do point containments, lines, intersections, polylines. So the simpler your geometry, the faster it will compute. And at the end of the day, every single geometry that is very complex is composed by small, very simple pieces of geometry. So you can always decompose anything into simpler pieces of geometry to which you can then operate.
Cool.
Okay.
And we have some comments. I'm a beginner, and I must say that those hints are very important at the stage when I know some basics and still in the early stage of learning. And this, I can also admit here that I was always just using shape components with some splitting components without thinking that can be a faster way. But after someone just showed me that it can be done really smarter way, so I try to create much more nicer and faster scripts. Cool. Let me see. Let's go to textures. Let's go to the next one. Next of the tips.
Perfect.
Oh.
Okay. So here I have another example. This is a perforation wall, similar to these ones. Now you see a lot in architecture. So this kind of perforation walls, and I think I've seen a lot in the Grasshopper community, people trying to do these kind of things. And well, how do you create that in the most efficient way while making making your model compute fast? So I enable this. Hopefully, it's gonna not break my model because that's the slow part. That's what you shouldn't do. That is basically what is happening in this model is I take a bitmap, I sample the bitmap. Okay, everything done. We are safe. Almost 50 seconds. I take a bitmap, I import it, for example, this puppy, and then I sample it in different points. And then I take the color of that that bitmap in those coordinates, and then based on the luminance in that point, then I decide the size of the perforation. Now, in this case, I'm assuming that we have a machine with these standard drilling radiuses, so that's why I snap then the sizes. I snap them here to the closest standard size that we have. Then with that, we end up with these circles, and this rectangle is the exterior of the wall. And then, well, the idea is, okay, how do we fill the in-between? No, we need to know what is filled and what is a hole. No, the simplest way is to do a boundary surface. No, and then the boundary surface does the magic, and the boundary surface is able to identify what is inside and creates the holes.
This is how I would do that.
Correct. Now that will take a long time, and you actually, for manufacturing purposes, you actually don't even need this. You need this mainly for visualization purposes. But for manufacturing purposes, I probably just need the coordinate, the drill size, and that's it. I don't really need to have this. It is just because I want to visualize it. So if for manufacturing purposes, if for manufacturing purposes it's not needed, then how do I visualize this? I just want to visualize. And then is when we can use textures instead. So what is this hole? This hole is basically just transparency. In a texture, you have, a material, you have many layers. You have the base texture map, you have the normal map, you have roughness metallic map, and you have also an opacity map. These are just images, so JPEGs, that you can create parametrically as well through Grasshopper. So there is a plugin called Squid. We have a version, ShapeDiver Edition, but there is also another version that is just Squid. And with that one, you can create parametric images. So in this case, I take these circles. Here I'm just creating the standard sizes. Here I'm just creating standard sizes as a polyline, as a polygon, because I'm creating an image. So an image is basically just pixels. So pixels are not perfect. Pixels are just basically rectangle that you start to fill. So that's why we need a polyline. Then I take these polylines. I could give it more resolution. It's just the amount of segments that I have here. For now, 12 is enough resolution if you see it from afar. And then I use this component from the Squid plugin called the Draw X component. That one is similar, let's say, to the boundary surface component. It identifies what is in and what is out. It creates an instruction, and this instruction goes into the Squid component that creates an image. So if I check that, this is just an image. I could already export this as an image and save it as a JPEG, and that's it. And you can even see the amount of pixels that it has, which I control actually also here. I know the size of my wall, and I am saying the maximum resolution is 2448 pixels. Then I do a division, and then that's basically the amount of pixels per unit that I'm gonna add into my bitmap, into my image, because also you don't want to have a 5K, 20K image. That's also going to affect your performance, and you don't need that. So that's why, for example, here I limit it so that it's up to 2K in this case. And then I use here a material component. In this case, I use in the ShapeDiver material component, but I'm pretty sure there is other plugins that also offer this, because this is just a standard thing. Creating a material is just a standard thing. In Rhino, you can also create. Probably Rhino 8 components now have a lot of things from, so Grasshopper in Rhino 8 has now a lot of components that normally were just something that you could access to Rhino. So you could create a material from there. And that creates then this result. So actually, if I check this, if I go Control M is going to show me the lines of the mesh. In this case, you can see that I just have the exterior one. So basically, this is just a one phase mesh. That's it. That has an opacity map, so it fakes transparency so that we can see through. So if I go to 3D, here we don't have anything below, but if I will put a box, maybe. Okay, well, here if that's gonna work. You can see through, you can see behind the box. That's because I'm using just this opacity map, so I'm faking these holes, because at the end I just need this for visualization. I don't really need this for manufacturing. For manufacturing, I just need the circles. And then you can use these textures to do perforations, even bump. Normal maps, for example, allows you to create fake bumpiness or fake textures in your geometry, so you don't have to geometrically affect the mesh or the VRAP, but you can just fake it through a normal map. That's somewhere here, normal texture. So this is a bit. If somebody wants to learn more about textures and stuff, they can check my the Shape Diver channel, and there I talk more about it. But with textures, you can really fake a lot of things for visualization purposes and get to the same result pretty much.
Cool.
Okay.
That was really great. Let's go to the next one, and I think one of the most important, like one of the last one. Let's go to meshes. Like people try to always work on the solids element and try to avoid meshes, but actually, when it comes to computing time, when you showed point, line, and then should supposed to be a mesh because it's much more faster. It's not that fast as a lines, but it's almost the same. So what kind of tip do you have here?
Yeah. Okay, so here, before we go to another example, I just want to show that I could also, if I do want to keep the perforations in 3D, I could then do it faster through a mesh. No, so here, for example, I have a rectangle, I have my circles again, I position my circles, but then I'm using this component. This comes from the utilities of the Shape Diver plugin, and then you have utilities, and here you have mesh patch. This is also something that you can find in the Rhino common. The mesh patch is a function. And then here, this function has many options. One option is the outer boundary. The outer boundary will be my rectangle. And the inner boundary, not the inner boundary, but the whole boundary will be my circles. And in that way, I can create in 3D all of these perforations. And then I can visualize that. So that's one quick way to still keep 3D, but doing it through meshes instead of doing it through surfaces.
There
So
is
let's
one.
go to.
Yeah, there is one component like the natively it's a surface patch, right? And this one is kind of the same. It's working in the same way, like a standard patch, I think it's called. Yeah.
Yeah, but that one I think is for surfaces.
Yeah. Correct.
Okay.
But for surfaces, but it's like for those who would like to. So this one is for mesh. I haven't seen that. I will make a note on that one as well. Thanks.
Yeah. And let's go back to the lamp one, where now we will use meshes instead. And we will see how that affects the speed. So here we have using meshes, and then here something that we have to consider is first, like, why meshes, no? Because you can see here, for example, okay, this took 65 milliseconds, no? And then I'm using still VRAPs, and this one is taking 66 milliseconds, so let's say the same, but I'm using meshes. So why do I use anyways meshes? Is in this case, it's taking the same amount of time. And the reason is because there is still one more thing that you have to consider when you use VRAPs. When Rhino is rendering your VRAPs, internally, actually, Rhino is meshing them as well. Because your graphic card actually is looking for primitives. Primitives are basically triangles, and triangles are basically meshes. So even though you are here working with VRAPs, if we check this, here I make VRAPs, and then if I go and I put the command what, I mean, what is this? And then you can say, okay, this is a valid poly surface, blah, blah, but down here you can say render mesh. So even though you see a VRAP in the background, to be able to visualize this in the viewport, Rhino has to convert this into meshes. So at the end of the day, this process can happen in the background that you don't even notice, or can happen explicitly. That's basically what I'm doing here. No, if I explicitly convert this VRAP into mesh, then you can see I have to add not just 65 milliseconds, but I also have to consider these amounts of time, which of course I could also optimize. No, if I just mesh one of the ribs and then I rotate, etc., I could optimize this as well. But just for you to consider that, that's why, anyways, we have to get to meshes at some point, because for the graphic card to be able to visualize this, you need meshes. This is even more, you can see even more this in the, I hope I didn't close it, the golf ball, but maybe I closed it by mistake. I don't know if you noticed when I had the golf ball. I don't see it open. Golf ball. When I was clicking the B wraps that contain a lot of spheres, my grasshopper was taking a little bit of time to. So if I just visualize this, here it's locked right now. I cannot do anything. It's locked. It's locked. It's still thinking. It's still thinking. What is it thinking about? Well, what is happening is that in the background, this is being converted into a mesh so that we can visualize it. That's why sometimes when you click to visualize something, it may take a long time if you have something complex because it's being converted into a mesh so that you can visualize it. So that's why it takes a while just for me to even visualize that.
Yeah, so you can also optimize visualization of the like, for example, in the complicated B wraps or surfaces. In this case, if you optimize, like you make it more mesh optimized, not that many elements, so that can also help with the rendering. And just one comment for those who are working with Tekla Revit. So it's the same as Rhino is changing every solid into meshes. So the same is, for example, with Tekla. Even if you see the representation of the nice like a B-wraps surface, so it will be always as a mesh.
Yeah, in general, that happens with everything.
Yeah.
So everything that you see in 3D anywhere, it's a mesh because that's when you go to the core of how you are rendering this. Your graphic card is looking for triangles because the triangle is basically just 3 points, and then that's how you start to reconstruct what you are visualizing, the pixels that you are visualizing. So whatever you see online, whatever you see in whatever 3D program, at the end of the day, even if it's a solid, what you're visualizing is a mesh. Okay.
Perfect.
And well, there was this question of the golf ball, how to make it faster. Use meshes, and then you will make it faster. This is not the one that I wanted to check. What was it? Because I didn't change here. This should be mesh operations. But here I just want to see, okay, what I did here to use mesh instead. So I am doing the same that I did before with the intersection. I'm using still the math options, but I'm using this component to convert. Instead of using the boundary surface component, I'm using the polyline to mesh component. This comes from the pufferfish plugin. And that one works like the boundary surface. It's just this one is not compatible with holes. Now, if you have holes, then it's when you use the patch mesh patch component. And then I can use, for example, you said I was using an offset surface component. Now you have also similar in offset mesh component, and then I rotate. And on the other side, for creating the ribs, I'm converting the circles into polylines as well. And then I'm offsetting with this component. This component is actually, maybe we can add that to the people that sign up because I think that's not publicly available yet. It's a component that our CTO, Alex, at Shapediver created because this component offset polylines while keeping duplicate points. The problem with all of the other components that you have available in other plugins is that if you offset and all of a sudden 2 points of a polyline collide, then it just gets rid of one of the points, which is not ideal when you are creating meshes because you want to be able to, it's like creating the wireframe. You're creating the different curves that are going to connect. And wherever you have two points, you need both because that means instead of creating a quad, you are going to create a triangle, but you still need 2 points. You still need 2 points. So here, when I create the mesh, I do it with this component called the loft mesh component, which is also something from the utilities section in Shapediver. However, there is other components also in other plugins, especially Pufferfish, mesh pipe component, parameter loft mesh component, mesh sweep component. All of these come from Pufferfish. In this case, I'm using the loft mesh component, which is looking to have the same amount of points because all what it does is I have here the wireframe and it's just connecting every single point. If I explode this.
Yeah, you have to have control over your data, over your line here about the how the curves are built.
Correct. So here, every single branch has 5 curves, no, and every single of these curves or polylines have the same amount of points, because all what this component is doing is connecting one point after another to be able to start to create every single one of the quads or triangles of your mesh. And that's why if all of the sudden you don't have the same amount of points, well, your mesh is going to start to look horrible, because all of the sudden the order of your points changed. So that's why you have to keep that same amount of points. And then that's how you can create a mesh from scratch in this case. And then I can unweld it, or depending on what you want, I need here to unweld it so that we can see very well the connection, the transition between one phase to another. And that's how you can then optimize a lot your script with meshes.
We have a question about the meshes. Are used only at the end, or can operation be done with meshes instead of with BRUPs?
So meshes, we actually at Shapediver very rarely use BRUPs, only for manufacturing. But other than that, we create all the meshes from scratch. We never go through a BRUP. And then there are also a lot of operations that you can do with meshes. So here, mesh curve intersection, mesh intersection. You have exactly the same mesh difference, mesh union.
And also checking volumes, for example, and area of meshes is much more faster. So
correct.
all the
and all of
operation
these exactly. So it's the same principle, no? If you take the shape section, it's going to take longer than if you take the mathematical section, but it's faster because you are working through meshes instead of working through solids. And here you have all of the mesh section, where you have also, for example, this mesh inclusion component. We had in the BRUP something similar, no? The BRUP inclusion component. So almost for every single thing that you have for a BRUP, almost, not everything, but for many, you have a component that works for meshes.
Victor asked, plane and mesh are the different entities? Yeah, I will answer yes, there are different entities. Plane is defined by 1 point and 2 vectors, and the mesh is defined by 3 points. So this is the difference between them. Okay, cool. Let's go to next example, right?
Yeah, I just
would you like to show something more, or yeah, sure.
Just one small thing here. Another good thing of having meshes is that in meshes is where you can then define also materials. No, a BRUP, some BRUPs already natively create automatically UV coordinates of how materials will grab around your geometry. But at the end, in the background, what this is doing is changing the UV coordinates, the texture coordinates of your mesh. So how the points lay down so that when you ungrab this mesh, you can see some material or something happening there. So if I use here this texture checker component, you can see how the mesh is laying down the material around my mesh. And that happens because this component has this option to compute UVs. So that's the UV material, and that's basically how the geometry how the texture is gonna lay down in my geometry. And then you have the UV size, which is how big is gonna be this, no? So how big is gonna be my image, the image that I'm repeating, because it's just an image that I'm repeating along my geometry. So here I go 1,000, then you get this size.
Actually, speaking about the UV, so we have the question: are there components that can divide meshes into UV components, like can be done with surfaces?
So to lay it down, to unwrap it, basically. I mean, there is two ways, because one thing is to unwrap it for geometrical reasons, and one thing is to unwrap it for texturizing reasons, for affecting the UV coordinates. If it's about UV coordinates of the texture, there is a component in Shapediver called the extract mesh UV component. and this one will show us how, like in 2D, how the UVs are being laid down. So if we check this, all of these are the points of the UVs. No, it's just the point. So it's just like if you take this and you just unwrap it. That's what, and then you could affect these points if you want, in the 2D space, because UVs are always in the 2D space, of course. And then you could affect this, and then you could use something like human plugin. Let me see what it is. And this one has this texture mapping components, and it also has this custom mapping.
This one with duck, yeah.
Correct. And then you could use the mesh that you want, and you could either create from scratch your UVs, or use this component, affect your UVs, and then reapply your UVs. But that has to do more about how the texture is going to be mapped around your geometry. That makes sense.
Perfect. Let's go to next one after the meshes. So let's go to one of my favorite optimization, and that helps a lot. It's really easy to apply. Let's go to transformations. And actually, for those who don't know the transformation, there is one component that actually every component in the move section, in the transformation section, this kind of has this transform. So maybe we can, Edwin can just zoom it a little bit and show us what actually does it mean to transform.
Yeah, so here in the transform section, you need to always, when we are talking here about the transformations, you have to look always in your components that it has this output transform. If it doesn't have this output transform, then then the component is doing something more than just transforming. If you take a flow, for example, it doesn't have that output. So it is actually changing your geometry fundamentally. Whereas when it has this transform, all what it's doing is changing the coordinates, changing the position, maybe just stretching it, scaling it, but it's not fundamentally changing the geometry. So you're always looking for this transform output. So here we are going back to this example of the perforation walls. And then there is another option that we could use. So you could see here that this took, still I'm using meshes here, but this took 124 milliseconds, let's say almost a second, let's say. And another option that I could do is, I know that I have standard drilling sizes, no? So I have my unit size is 55 millimeters of unit. And then I have here my standard perforations. And then with that, I can create, using the same mesh patch component, I can create the mesh that create my standard holes. And then I can move them in position because I have them already grouped, no? I have here in this I showed before, no, where I have all of my points completely disorganized, let's say, and then I group them by size. So I know that every single branch here represents a number of the sizes of the standard sizes that I have here. So that means that every single branch here can be moved to all of these points that I have grouped, so that at the end I have the same result, but in this distribution. So if I go Control M, so we don't see the vertices, the edges, then we can see this is pretty much exactly like this in terms of visualization. But of course, to way less time, because we are transforming. In this case, the transformation is just to move. This is the first example, but you can take this to an extreme. And then here I have this example of a pergola. This pergola was created completely using transformations. So if I check here at the complete end, we can see here a bunch of transformations. So this symbol is a symbol of transformation. So it's not geometry, it's just transformation. And the only geometry that I have is this mesh, which I call it unit mesh, which is basically just a cube of 1 by 1 by 1 unit. And then I apply to this cube all the transformations that I want, and I end up to this result. So with that single cube, basically, I'm not even creating this cube. I'm internalizing this cube. If I check here, it's completely internalized.
This is really actually a really extreme example. I've never seen that. So basically, from this 1 unit cube, you are building all the segments with just copying elements, like moving elements and rotating with this. This is fun. And what was the result? It was really fast.
Yeah, and then it's like you are basically, because here I'm creating zero geometry. I'm not creating geometry. All what I'm doing is transforming a single cube. And then, of course, I mean, it's actually a good exercise also, because then you have to think about in a more how do you say, not explicit way, but because here I'm just working with coordinates, with numbers. I'm not explicitly building the geometry. I'm just thinking, okay, I know that this coordinate has to be here, and there's, for example, here the columns. I'm here saying I'm here just okay. I know these are the points where my columns need to be, and I'm using the scale NU component to scale the cube based on the frame size and on the height.
So scaling in 3 direction, right?
Correct. And then here I have the beams, for example. So again, I have to think, okay, where is the position of my point, the origin? And from this origin, I'm scaling. So because first I have to position, and then I have to scale, no? Then I do the same point and scale. And then what you need to use there is then this compound component. This compound component basically joins transformations. So you have here a move, and I have here a scale. First, and the order matters, no? You have to implicitly, I mean, you could explicitly do it if it's difficult for you to do it implicitly in your mind, just to know, okay, I have to imagine that I'm explicitly here transforming my cube, no? That means the best is to do it in the origin, no? Because otherwise, if you do it off the origin, that transformation is going to apply also to the position in which your geometry is in respective to the origin. So it's better to do it from the origin, and then I move. No, first as a scale, then I move wherever I need. And then basically I'm doing the same with absolutely everything here. Scale, move, scale, move. I mean, I could use, for example, here I have the rotate. I think this one is the lower, so that's the back part. No, which
because they are tilted. Yeah, because they are tilted. Yeah.
So I am scaling them first, then I'm rotating them, and then I'm moving them. So it's 3 transformations for every single one of these ones that I have here.
Really cool. And I never even thought about this example, but it's a really if I can imagine how to show the transformation, this is the best example that you can show. Cool. Let's go. We have already 1.5 hours, so let's go to our last tip. Will be the operator. So we will finish that. And then we will have some time so if you will have Edwin some time afterwards, so we can answer some questions.
Yeah. So this one is a bit charged because I think there is a lot of engineers here, maybe. So we will be talking a bit about Python. So I went back into this example. And then again, I'm sampling my points, my colors. So the colors of the image in different points. So in this case, I have 2,475 colors. And I want to do some operation in the RGB code, the RGB factor of each of these colors, RGB numbers. So there are very, very different ways that you can do that. This is an operation that needs to be done so that you can create a sort of distortion map of.
Can you zoom it? Can you zoom? Can you zoom a little bit more? Yeah, cool. Thanks.
If you were to create like a kind of normal map, but in 3D, then you can do an operation there. And then, for example, here is just a multiplication by a factor of the R, a multiplication by a factor of the G, and a multiplication of a factor of the B, and then a sum up of all of that. And then I try to do this the same operation but in different ways. No, so as you can see, we have different results. If you use an expression, you use 293 milliseconds, but you could get to the same result just with 43 milliseconds. What's the difference? So first, an expression takes more time because the first thing an expression needs to do is to interpret, to figure out what is it that you wrote here. No, you are not explicitly telling it, you are doing an expression. So the first thing is to interpret what you have there, and that's why it takes more time, and then actually does the operation. So this one takes more time. Then you have C# and Python. We as Shape Diver, we always recommend using C# because it's normally faster to compute. As you can see here, is significantly faster. The reason is normally because Python is compiling all the time on the fly. Whereas C#, as long as it compiles once, normally it takes a bit longer when it compiles the first time, but after the first time, it is already compiled, it's just zeros and ones, and then it just gives you a result straight away. Whereas Python needs to be all the time compiling, and then it takes way longer. And then we have a simple but very important error that many people do and have seen. That is, for example, here, I'm using a panel to do a multiplication. What happens here?
Correct.
The problem of using a panel is that a panel is actually text. Whenever you use a panel, it's text, it's a string. It's the same as if I do this. If I were to do this, internalize, this is the same as this. So what happens that when I go and do a multiplication, then this component needs to first cast, needs to convert this text into a number to then multiply it by the A and then give you a result. This transformation from a text to a number takes a bit of time, which can compound into a lot of time if you have a lot of numbers. No, so this is happening for every single of these 2,475 times, which of course compounds into too much time. And if I do it then along all of these, then, well, that starts to sum up. It's not that bad, but also I could add way more perforations in this wall, and then it will be a disaster. Because this wall is still not, could have more resolution. We could have way more perforations there. And then we have the best result. The best result is similar to the previous one. It's
but
just
with the
that
numbers.
Instead of using a panel, I internalize in a number, and then I already have it there. There doesn't need to be any conversion because it's already a number. So the multiplication just happens immediately, and then we end up with the result. So you saw the other one was taking like 90 something milliseconds.
Yeah.
It takes 8 milliseconds.
And here just because before when we talked about spaghetti monster, there came questions, and I'm really interested in your answer. Do cluster impact performers in any way, or is just a visual order? Is Mario also asked about that? Because when we talked about the spaghetti monster, a number of components in the script.
No, I mean here people don't have to get confused. The reason why I'm using here cluster is just because then it's easier for me to show you how much time is taking. It's not like I'm clustering everything. Here is just for order first, but also to show you, because then it's a good way for me to show you how much time is taking when you sum up everything. But anyways, does it affect the speed? Normally it improves it, but it has to be in a very big model in which you are using many times the same cluster. Because if you were to save this, so there are two ways to save Grasshopper file, either as a binary or as a XML. If you save as an XML, you will see then what is like actually being saved in a text format. And a cluster is just an instance that is saved once. So you have an instance that is saved once, and then you have just in the XML you will see, okay, that instance is called here, is called there, is called there.
It's like a function. So it's like a function in programming.
Exactly. So it's just like how would you say? It's just compressing, let's say, the amount of times that you're using something. But you have to be also you have to also decide when it makes sense to use clusters and when it makes sense to use data trees, because sometimes people think clusters is a way around of data trees, and no, you should use data trees always. And the only reason why when I would use clusters is if I want to use this function in complete different use cases inside my same definition. If it's the same use case, if I'm just looping through the same thing, I use data trees.
Yeah, this is, I think, a great answer for this question. Cool. Yeah, we have already some time exceeded, but maybe we can also at the end mention some useful plugins. Do you have it? Do you have any list, or would you like to just mention?
I will just mention them.
Cool.
Okay.
No
during the webinar, I've been already mentioning some, the workshop. Yeah. So pufferfish. Maybe you can share my screen. I can just show you.
Yep.
Okay. So if I go to pufferfish, you have here many mesh operations. No? So we were talking about mesh are very important, but we have also, for example, transform operations here and everything in between. So I use a lot of pufferfish to be able to, for example, I could twin between curves, and then in that way I can then create the wireframe of a soft surface. If I want to create a surface that looks smooth but in mesh type, then I could use a twinning of curves and construct my mesh wireframe. So a lot of these, basically pufferfish, I mean, everyone I think knows pufferfish, one of the most downloaded plugins, and it gives you way more control over your geometry. So I use that one a lot. Then we have Weaverbird. Weaverbird is actually specialized just in meshes. That one I think I've seen the jewelry industry use it a lot. I don't know which other industries, but this one also has many options to manipulate the meshes. So you can have a look or even create meshes from scratch. Then we have Bowerbird. This one I already showed before as well, and that one is the one that has these polyline operations, very fast and useful. Clipper I already showed again as well before. This one has also polyline operations, containment. Also, it has a Boolean option, so also very good. Mesh Plus. I think it's this one. And Mesh Plus is also for manipulation of meshes.
Mesh Plus, yeah.
And many options and many also for doing analysis in meshes. And then, well, the last one will be in Shape where we have utilities, and then in utilities we have a few components that we offer for optimization reasons.
I have to check this patch mesh one. Cool. That was really great workshop. We have amazing comments like this one. This is probably the most valuable webinar of last times because of the tips might be useful literally for every Grasshopper user and all spheres. I definitely must rewatch this webinar 100 times. 100 times again. So this is a really good recommendation and good work. Great work, Edwin. Thanks for sharing your tips. For those interested in more webinars, we are having next Learn Grasshopper live session in 2 weeks. It will be more about Grasshopper and Python, how we can work with that. The Stein from Victor will be my guest on that one. We have great comments, Prim, great webinar. Let me see. Do you have, Edwin, still some 5 minutes to answer the questions?
Yep, I have.
Perfect. Do you ever experience lag, screen freeze when jumping from the Grasshopper canvas to the Rhino viewport? If yes, do you have any solution on how to solve this problem?
I think the only time when that happens is maybe what I showed, where if your geometry is very complex and then when you want to visualize it, then Rhino has to mesh it automatically. That will be the only case in which I see that it's freezing when I want to go to the Rhino viewport to visualize the geometry that I have in Grasshopper. Other than that, I don't think I have any issues with that.
Yeah. Cool. Let me see. First question: what factors makes Rhino and Grasshopper decide to create a geometry as a BRAP polysurfer instead of just a surface?
I mean, that's
It's
basically how you create the geometry.
but it's not like a volume. It's not like a volume. If there is a volume of the, if Rhino recognizes this object has a volume, so it will change that to BRAP.
Not really, because there are also some cases in which, I mean, a poly surface is just a combination of surfaces, no? So you could have still a open BRAP that is still a BRAP. It's a poly surface, but it's still, I mean, depends. What do you consider everything is a BRAP at the end. It's a boundary representation. It's just, is it a surface? It's a poly surface. But I mean, that's a good question. I'm thinking, for example, there are some cases if you use the loft component, let's just call it here, the loft component. This one creates directly a BRAP, and sometimes it could. So there are some geometry that you create that could be still represented as a surface and not as a BRAP. So you can see the output is still a BRAP. Probably internally it's just a surface. It's just, remember, these are just data types. Data types here, they decided that the data type is going to be a BRAP, probably because there are cases in which, depending on the keywords that you provide, the output could be a surface or a BRAP. I mean, a poly surface, because both are BRAPs. That's why you need a more generic. That's why they decided to put a BRAP there, because you can sometimes have a surface or sometimes a poly surface, depending on the input keywords that you give. However, for example, sometimes you can use pufferfish, and then in surface you have this unsplit extrude surface. No, but there is also a loft one, I think. Yes, on a split loft surface. This one outputs always a surface, for example, which is sometimes better also in terms if you want to then convert this into a mesh, it's gonna be normally a way cleaner mesh. So if you need to really output a surface, you need to make sure that the component that you're using has as the primitive. Now you can see the primitive. I don't know if my screen is too small, but the primitive of this component is a surface of this output. Is a surface.
Where this component? Can you say again where this component come from?
It's in pufferfish.
Okay, it's pufferfish.
In surface section, and then it's on a split loft surface, and they have similar for other things on a split extrude surface. So all of these ones will always create for you explicitly a surface. Now you need to check your use case. Now it's always a matter of use case. The thing of having an split surface is that, of course, wherever you have a change of direction or something like that, because it's unsplit, then if then you convert this to mesh, or then you need to manipulate this, you will not have an edge anymore there. That's why it's unsplit, because it's completely continuous. You don't have an edge. As soon as you have an edge in between, that becomes a poly surface or a BRAP.
Cool. Let me see this one. And does some plugins have a checkbox component that works like Boolean yes, no, but in the way of checking, unchecking checkbox? Like item selector. I think this is the one. Item selector. Yeah, this one. It can be also like a checkbox. So this can be check yes or no. But also. And I think also one which is called, which one is item selector. It's I think it's from the human plugin. I think this one. So I think in this one you can also right click, check it to checkbox.
Yeah, I think you need to have something.
Yeah, yeah. So for example, and if you right click on the item selectors, I think you can change to checklist. A little bit, yeah, this one. Yeah, so you can choose actually by checking. So actually you can choose which one you would like to select as an output. So it can be cool one. Maybe not with this huge list as this one, but it can be great interface if you would like to have several options to choose, like in the checkboxes. So Victor, so you can choose one of them. Bravo, Edwin, many thanks. So we have still almost 100 people with us, so they were really interested in topic. So that's all. We answered, I think, all of the questions. So congratulations for everyone who would like to check more Edwin work. I really recommend to go to YouTube channel of Shape Diver. And check out all the tips. I learned from them a lot. So after watching that, if you like all the tips, so for sure you will like. Maybe in the future we are going to do with Edwin more webinars. Maybe write some thoughts about it. If yes, so just write some comments. Thanks for sharing all the 12 tips and all of the plugins. They are useful. All of us we've seen that you had many of the components, many plugins and add-ins installed. But for those who are not experienced with Grasshopper, don't be scary. After some experience, you're going to get used to it and just use the most important for you. From Liam, thank you. Great lecture and very, very helpful. That's all for me. Would you like to add something at the end? I think there is one thing that maybe you would like to say.
Yeah. So we have. Okay. Well, first of all, check our YouTube channel. Give me 1 second. I have something to prepare. Okay. So first of all, check our YouTube channel. Here we have many. So many of what we covered today you will find here in the YouTube channel. Transformations is here, and all about optimization, meshes versus V-wraps. All here you have the example of the golf ball. So a lot of things are here that you can learn from. And I would like to also invite you for a webinar that we have next week, next Tuesday, the 8th. Where we will be talking about the updates that we have at Ship Diver. So we are working now on something called the App Builder, which will allow you to create more advanced web applications, cloud applications, just with Grasshopper. So just with Grasshopper, you will be able to create very, very complex applications. So if you want to learn more about that, join us next Tuesday.
Perfect. So for everyone interested, next Tuesday, maybe you can you copy this link and just put it on the chat? So people will know it. So yeah, 8th of the October for those who are interested how to make it on the Grasshopper script on the cloud. Again, thank you very much. I hope to see you on the next webinar after we got so many good feedback about the presentation. So we all hope that you are going to produce more optimized script and they will be faster. So even if you will take just one lesson from this webinar, so we will be happy that your scripts will be faster. So again, Edwin, thank you for your time. It's been almost 2 hours, but I think it was could be for Grasshopper user most valuable 2 hours. If you spend 2 hours, for sure you can spend a month of standing and just figuring out how and why your Grasshopper script are so slow. So that's all. Thank you very much and see you on the next Learn Grasshopper Live. Bye-bye.
Thank you.